Okay, indices. So just general rules about powers. If you've got a times b to the power n, then you can split across a multiplication. So a bit like with the square roots. And a over b to the power n, you can split across a division, but warning, I'm sure I've told everyone this quite a few times already, you cannot split a square root across an addition, so just be careful about that. If you think about it, if you've got a plus b squared, you have to multiply out two brackets and you get a squared plus 2ab plus b squared, which certainly isn't a squared plus b squared. So yeah, but do use these. So general rules, some of these you'll be quite familiar with. So first one, if the base is the same, so you've got base a power m times a to the n, then you add the powers. So e.g. 2 cubed times 2 squared is 2 times 2 times 2 times 2 times 2, so you end up with 2 to the power 5. A to the power m divided by a to the power n, you subtract the powers. So, I don't know, 7 to the power 5 divided by 7 squared. 5 minus 2 gives you 7 cubed. That's because you've got, essentially, if you write that as a fraction, 2 of those will cancel off and that'll leave you with 7 cubed. If you've got power to a power, so a to the power m to the power n, then you multiply them together. So e.g. 4 squared cubed is equal to 4 to the power 6. Sorry, it's a curse of being left-handed, it's smudgy boards. Slight improvement. So if you think about it, you've got 4 squared times 4 squared times 4 squared, so you're adding 2 together 3 times. So 3 lots of 2 is 6. A to the power 0 is equal to 1. So just to show you that happening, if you've got 3 to the power 4 divided by 3 to the power 4, when you divide, you subtract your powers. But we know that 3 to the power 4 is 81, and 81 divided by 81 is 1. So it follows that 3 to the power 0 is 1. The only exception to that is 0 to the power of 0, which is undefined. A to the minus m is equal to 1 over a to the power m. So for instance, 4 to the power minus 2 is equal to 1 over 4 squared. You could kind of do something like 4 cubed divided by 4 to the power 5, just to see that happening if you wanted to. And then you can see that the top 3 cancels off, leaving you with 1 over 4 times 4, which is 4 squared. Rule number 6 is, I mean, it's really the first kind of 5, but these kind of fit in with this as well. Rule number 6, a to the power 1 is equal to a. And again, you could see that because, say you've got 5 to the power 4 divided by 5 cubed, then 4 minus 3 is 1. And then if you've got 5 times 5 times 5 times 5 over 5 times 5 times 5, these all cancel off, and that leaves you with 5. Rule number 7, root A is equal to A to the power of a half. So, for instance, root of 8 is equal to 8 to the power of a half. It has to be half. So if you've got 8 to a number times 8 to a number is equal to 8. Remember, 8 is the same as 8 to the power 1. When you multiply, you add your powers. So 2n must equal 1, and n must be a half from there. And then following on from here, we can talk about an nth root. So the nth root of A is equal to A to the power of 1 over n. So for instance, the cube root of 5 is equal to 5 to the power of a third. And if you do 5 to the third times 5 to the third times 5 to the third, you add your powers to get 1, and then you get 5, which is what you expect for a cube root. So I want you to do some non-calculator work on this to start with, please. I'll go for a few examples. So e.g., write in the form (5 to the power n). So just to get used to manipulating into indices form, because you'll need this for the differentiation. So 1 over 5 is 5 to the power minus 1. So that was one of our rules. Yeah, I think you should be okay with that one. B, 1 over 125 is equal to 1 over, this is non-calculated stuff, but to find out, you know, what power 5 is, it's not going to be that high, so don't worry about it. So 5 times 5 times 5 is 125, and then that's equal to 5 to the power of minus 3. So that's using rule number 5, both of those. And then C, if we've got 5 root 5, we've got 5 to the power 1 times 5 to the power of a half. 1 plus a half is 3 over 2. So we're back to using top-heavy fractions and no decimals again because we're pure maths. So 5 to the power 3 over 2, and 1 over the square root of 5 is 1 over 5 to the half, and so that gives us 5 to the power of minus a half. And I'll just do a few more, so we've got a clean board. I'll rub that one off again. So e.g., simplify 2x cubed plus 4x to the power of minus 5. So 2x cubed means 2 times x cubed, and sorry, that's going to be a times. I was just thinking that wasn't going to simplify then. And 4x to the minus 5 is 4 times x to the power of minus 5. And you can, when you're multiplying, it's commutative, so you can swap the order around. So this is the same as having 2 times 4 times x cubed times x to the minus 5. So 2 times 4 is 8, x, and then adding the powers, we get minus 2. And then part B, if we've got 12x to the power 4 divided by 3x to the minus 1, then you can do the numbers first. So 12 divided by 3 is 4. And then x to the 4 divided by x to the minus 1. I'm subtracting the powers. So it's 4 minus minus 1. So that goes to 4x to the power 5. And then if we've got what I've written on here now, the cube root of 7 to the power of 5 over 4, to simplify, then that's the same as having 7 to the power 5 over 4 to the power of a third, so that's the cube root power. And then power to power, we multiply them together, so 5 over 12 on there. So if you could work through, I'm pretty sure actually this is all non-calculator work. I think you can do this whole exercise without a calculator. Yeah, you can. So these are the questions to focus on. So it's page 30, question 1, question 2. So it's the same thing. We're going to start non-calculator, and then your calculator will just do it all for you, but you need the techniques there. So question 7, question 8, question 9, question 11. So they're like the ones to focus on, but if you want to move on to the more difficult questions, if this feels more like revision, then do so. So they're the kind of problem solving and red ones towards the end of that exercise.